Invented in the 1920s, the rising stem ball valve was the only mechanical seal ball valve in the market. One powerful benefit of this valve design is that it can switch on and off completely free of ball and seat friction and therefore eliminate seal abrasion. The result is that this seal can last much longer than traditional ball valves. While closing, stem moves down and the lower wedge surface of stem squeezes the ball to tilt and compress the seat. Single mechanical seal can be achieved. However, this 100-year-old technology does have weaknesses. Firstly, it is obvious that the ball-to-seat alignment is very critical for the mechanical seal. Foreign matter can accumulate in the trunnion housing, which changes the ball-to-seat alignment. This misalignment can cause leaking. Another challenge is material wear on the stem wedge surface and core pin. As the mechanical seal load must be transferred through this very limited contact area, it can easily cause the material to wear and the valve to fail. And finally, it has only one seat and therefore only one mechanical seal can be achieved. In many applications, such as piping needs isolation for maintenance, switch piping processing, prevent product contamination. Positive isolation is so critical a DBB and/or DIB is required. According to API 6D, DBB and/or DIB as shown here requires 2 blocks and 1 bleed to stop the pressure from one side or both sides and create an air gapping by bleeding the space between the 2 blocks, so that higher level of isolation can be accomplished. Which means that 2 rising stem ball valves will be required as shown here for the function of DBB and/or DIB. This system is very complicated, bulky, and full of potential leak paths. Let's optimize this system in depth by maintaining the beautiful feature of rising stem ball valve and overcoming all its design shortcomings. Obviously, the valve ends, seats and blind segments on both sides are directly responsible for mechanical seal. Remove the rest, then compress the length of the 2 sections. Slightly modify the blind segments. What we need is mechanism to provide the proper seal load for 2 blind segments. This is the mechanism. A rotating threaded shaft mechanically loads equal amounts of force onto the 2 wedge segments, which in turn load the blind segments evenly, and under equal and balanced force onto the stationary seat faces. 2 mechanical seals are accomplished. Free space of ball assembly automatically solves the ball-to-seat alignment. The mechanical seal load is beautifully distributed with no stress concentration at all. Rising stem ball valve design shortages are perfectly overcome in the new design. In addition, we have modified the wedge segments and the shaft into a rotating ball assembly that maintains the function of providing a mechanical seal evenly to the spherical blind segments, but that also provides open and shut performance for material flow. Lastly, the subassembly is matched with a center body with single stem operating mechanism and trunnion mounted. When opening, the ball assembly retracts the segments, then rotates until it is fully open, allowing for friction-free movement between ball and seats. It is full port in open position. When closing, the ball assembly first rotates to the closed position with ball and seats friction-free, then the stem drives the ball segments to expand. The blind segments press the seats under mechanical load to achieve balanced mechanical seal. Bleed the cavity, positive isolation with DBB and DIB is functioned. The next generation mechanical seal ball valve technology is patented in Canada, the USA, China, and is patent pending in the EU and Japan. To view our prototype and discuss how we might work with your firm, please contact us.